Yes, welcome once again for the same chapter, that is programming of 8085. I think in the previous session we have studied about operands. Now let's see what is there in this session. I think this session it is related to operands only, but our topic is known as addressing modes. Okay, in 8085. Now what do you mean by addressing modes? The way of specifying the data to be operated by an instruction. That is nothing but an operand. Okay, or you can say the various ways of specifying the operand is called addressing modes. I think just now you have seen, or in the previous session you already know that we were having four types of operands like registers, data, memory, address, like that. So in this session also we are having five types of addressing modes. So how to specify different ways operands is known as addressing mode. So addressing mode is clear. How the various ways of specifying the operand is called addressing mode. So types of addressing modes in 8085 microprocessor, there are five types of addressing modes. Okay, immediate addressing mode, register indirect addressing mode, direct addressing mode, implicit or implied addressing mode. So today we'll try to cover all this type of addressing modes. Okay, now in this first we are going with the immediate addressing mode. Now remember that in immediate addressing modes, all the instructions will always ends with I. Okay, instructions will ends with capital I. Okay, that is very important way to identify. Okay, so right now let me read. In immediate addressing mode, the source operand is always data. Okay, if the data is 8-bit, then the instruction is of 2 bytes. If the data is of 16-bit, then we call it as a 3-byte instructions. So I hope you got that in immediate addressing modes, data is always present. Okay, so remember that data is present. Okay, in the operand part. Okay, data is present in the operand part, that is in immediate addressing mode. And can you see all the instructions ends with I? For example, here I have written MVI example, MVI B, 45H. Now what is 45H? I have taken random data and that will be stored into B register. Can you see? Move the data 45H immediately to register B. That is the meaning of this instruction. So I hope you understood what do you mean by I. I means immediate data. Now for example, LXI. Now remember that wherever in instructions if you find X means pair. So H. So H case, I think with H we are having a pair of L. So HL pair. So HL pair will be storing this data because to store data, 16-bit data, we require 2 registers. So you can imagine that H and L will be storing, H will be storing 30 and L will be storing 50. So can you see 30 and 50 will be stored in register known as HL. So I hope you got this. What do you mean by immediate addressing mode? First of all, addressing mode means in which the operands are specified. So one of the operand is data. So in immediate addressing mode, data is always present. If we are having 8-bit data, can you see we are having 8-bit data, then this instruction is of 2 byte. And if we are having 16-bit registers or 16-bit data, how you come to know it is 16-bit data? Because it is written as 3050. So this will be storing, every digit will be taking 4 bits. So there will be 16-bit. Okay, and if in the instruction if you find X, that means they are talking about register pair. Okay, and I think you understood that how to store the data. H will be storing 30 and L will be storing 50. Okay, now let's go with the next addressing mode, register addressing mode. In register addressing mode, the data to be operated is available inside the registers, and registers is also in operand. Therefore the operation is performed in various registers of microprocessors. And remember that all this addressing mode, our register addressing mode instructions are always 1 byte. And remember, this line is very important. Registers are present in the operand part. Okay, now when you check the operand part, I think I explained you, move is an instruction part and a comma b is nothing but a operand part. But in operand, which type of operand they are? They are register type of operand. That's why they belong to register addressing mode. In the previous case, I think when you look at the operand part, register is also there and data is also there. But since the data is present and if the instructions are having I in the instruction, then we call them as immediate data or immediate addressing mode. Okay. But in register addressing mode, exclusively only registers will be present in the operand part. So A comma B. So the contents of B register will be moved to A register. Okay. Now what do you mean by add B? Add B. Can you see operand part is having only B? So the add the contents of register A and B and store the result in the register A. I'll explain you or we will take some more examples when we'll do some programming. But right now you can understand this much. INR A. Now what do you mean by INR A? Increment the contents of register A by 1. Okay, so we have to increase +1 or we have to increase the data contents of register A by 1. That is the meaning of register addressing mode. Now let's go with the direct addressing mode. What do you mean by direct addressing mode? I think all the instructions are of 3 bytes. In this direct addressing mode, the data to be operated is available inside the memory locations, and that memory locations directly specifies as an operand. Okay, so address will always be present in the operand part. Okay, the operand is directly available in the instruction itself. So now what is very important to look here, address is directly present in the operand part, what they mean to say. Now when you look at the operand part, can you see LDA becomes a instruction and 2050 that becomes your operand. Now what do you mean by 2050 here? This is nothing but an address. Now you will be confused how to differentiate whether this is data or whether this is address. Now when you see more instruction, that time it will be clear. Now what is written here? What is the meaning of LDA? Load the contents of memory location to accumulator. Okay, whatever the contents of accumulator, whatever the contents of memory location is there, that will be given to the accumulator. Now same way we also have LHLD address. Now address is how many bit? 16 bit. Okay, so address is mentioned here. Load the contents of 16 bit memory location into register H and L pair. Okay, so now as I was telling you, you have to, in this case you have to just remember what is there in the operand part. If in the operand part address is there, that means they will be in the direct addressing mode. So I hope you got this. Now we are going with register indirect. Now remember that in any of the instructions, if you find M, okay, I think I should not be used, only M, that becomes a register indirect. Okay, and let's see what is there. In register indirect addressing mode, the data to be operated is available inside a memory location, and that memory location is indirectly specified by the register pair. So we don't have a direct address here, the address is hidden. Can you see? Address is very important thing, is the word is address is hidden in the operand part. Okay, address is hidden in the operand part means it is like indirect. Okay, and you will not come to know where is the address. Now can you see move A comma M? So whatever the contents of M is there, that will be moved to A. So move the contents of the memory location pointed by HL pair to the accumulator. I think in the previous examples also you have seen that M means contents of register, contents of HL pair. For example, I think I'll just try to explain you. Suppose M is having the contents like HL pair. HL pair will have some address like 2050, and at that address, suppose if the value is 95, so ultimately M is also going to store 95. That is the meaning of this. So it is indirect, because first you have to go to HL pair. HL pair will give you some address, and that address you will be having some data, and that data will be given to M. So M is little complicated, not complicated in the sense, you can say first of all you have to search one pair. That pair is nothing but HL, because M means HL, and HL will be having some address, and that address you will be having some data that you have to store it in M. Okay, same way here also, LDX B. Now don't get confused that B means register. It should belong to register addressing mode, because of the instruction. Sometimes you also have to check instructions, move the contents of BC pair to the accumulator. So whatever the contents, like BC pair will be storing some address, and that address will be having some data, and that data will be, instead of giving in this instruction to M, we should give it to accumulator, that is A. Okay, I think the meaning of this is load accumulator indirect. Okay, now when we'll go through it, we'll come to know. Okay, now we will be going with the implicit or implied addressing mode. Okay, implicit or implied addressing mode. In implicit or implied addressing mode, the operand part is absent. Very important. We don't have any operand only. Okay, we don't have like register, data, memory or address. Okay, we are having directly only instructions, CMA. Now most of these instructions are associated with accumulator, that is by default. Okay, now what do you mean by CMA? Can you see we don't have any CMA? After CMA we don't have anything, so we don't have any operand part. Okay, finds and stores one's accumulator of the contents of accumulator A in A. Now what do you mean by one's complement? Like replace 0 by 1 and 1 by 0. Okay, whatever your value of accumulator will be there, that will be just complemented. Now what do you mean by RRC? Now rotate accumulator right by 1 bit. RLC, rotate accumulator left by 1 bit. So remember that this is nothing but we don't have any operand part here. We have only only instruction part. So I hope you understood all type of addressing modes. So let me take you one step back. Okay, so can you see, first of all we are having immediate addressing mode. In that very easy to understand that I is present. Then we are having register addressing mode. In the operand part we are having only registers. Direct addressing mode is very simple. Here we always have address. Okay, in indirect addressing mode, register indirect addressing mode, the address is hidden. Can you see? And finally in implicit or implied addressing mode, operand part is absent. Now why I'm teaching you all this? Because this is very important when we'll do some when we learn all the instructions and the programming. So I hope you understood. We'll meet in the next session. Thank you.